Let's go ahead and get started. It was requested to show a little bit more about some of the features that's in some of these virtual machine labs or virtual lab. For example, if I click this lab 7.1, click start assignment now. Give you some instructions. You click the start.
Type the ls command and observe the result. Use the output redirect,
And I don't know
the
if there's
right
any way
arrow
to
symbol,
silence
to
that.
redirect the output of the ls command into a new file
But
called
the
new
instructions will walk you through what to do. And also it'll tell you over here what to
View
do.
the contents
It
of
says
new
type ls.
using the cat command.
And then redirecting it, use the
Two
greater
output
than.
redirect symbols will append the standard output to an existing file.
Then cat.
Entering
To view it.
ls-l.
Two greater than
output
symbols will append. So they tell us to ls-l.
We'll add a long list to the
greater than new file.
View the contents
View
of
the
new
contents
file
again using the cat
command again.
Like that.
The input redirect.
And then it takes you to the next item.
Oops. Will redirect standard.
There we go. So like this right here says the input redirect will redirect to standard input and so forth. Says type tac, new file. And you see the results. You can use both input and output redirect to redirect it. So it says enter the command tac, new file, and then greater than lfym. Use the cat command to view it. FYM. And clear screen when you're finished. So press clear. So again, it just walks you through with instructions. And that's that piece there. You just go through and do all that. Now that was the virtual lab environment here. For this virtual machine lab, you click that. Click Start Assignment now. Okay. Now this gives you some overview of what to do. Over here, to turn on one of these machines, you can come over here and you see there's a power on. So if I click the power on, then you'll see those go through and power on. Click power on there to bring that up. Now while those are loading, actually I guess those two are on, aren't they? Once it's on, then you can power it off by choosing this. You can reboot by choosing this, reset, suspend, refresh. And these are like little mini systems that you can access. Like this one right here. Which one's this? PLab Fed 01. I'm guessing this is a Fedora. Trying to think what the Ubuntu UB, UBT, UBTU, and Win Console. If you click this, this is obviously Windows, so I couldn't tell you what version. Probably Windows 10 if I had to guess. Okay, now this will give you a little bit of an overview Talks how to, no, that's Windows Server. Never mind. Fedora, Ubuntu. Go through, read all that, and then you click the next one, you'll go to the next page. Just customize and use a shell environment. Task 1, log into a Linux system, perform any operation. Okay, so ensure you have powered on required devices mentioned in the introduction to the exercise in the video. Connect to the Win console. So you click here to be on your Windows one. And you'll be logged to management server. You should see the desktop. On the desktop, double-click PuTTY. So double-click the PuTTY here. PuTTY configuration appears. In the PuTTY configuration, select plab fed01. So this one right here. In the load, save, or delete a storage session and click load. Ensure SSH is selected as a connection type. It is. It's right here, selected. And then click open. Command shell is launched and the login screen into the following. So we're logging in as root. Press enter. And it says wait for a couple seconds. Allow the root at plab fed01 password to prompt to appear. At password, enter password with a 0 for the where the O should be. So uppercase P A S S W 0 R D. It talks a little bit about that. You have successfully logged into the plab fed01 system. Task 2 lists the profile scripts and gives you information about that and so forth. I'm skipping over that, but the idea is that you'll learn how to do these items, so be sure you read all that and understand it. It says to clear the screen, you type clear. You will view the global profile first, so you do a cat. Let's see profile. Look through this. Google some of those if you want to know what they do. It's also presented in the book, some of it, not all of it. Step 2, let's see, profiles displayed. Step 3, clear the screen. So we're back to doing a clear. The dot profile is activated when user logs on, and so forth. It says enter the following command. Dot profile. No output is displayed. It loads the current profile. Dot bash underscore logout is another file that is login shell cleanup file, which is executed when the login shell shell exits. Enter the following command. Dot bash logout. Anyway, go through all this. Now, some of this might take you some time, and you may be watching this down here thinking, okay, I got 56 minutes left, or it gets down to 3 minutes. To extend your time, you just simply click this auto logout option here, and it'll reset it to 60 minutes. So you're really unlimited on how much time you got there. Obviously, you can't go away for a 2-hour movie and come back and do it. But after you finish all these, then you click next, and eventually you'll get to the point where you click the done because you finished everything. You see there's a view printer friendly content here. There's a toggle log panel visibility. So if I click that, maybe you prefer to have it in this format so it's easier to follow, so you can print this. Now it'll log out of these automatically, but if you wanted to power them off, you could just choose power off feature. Now there's access your practice lab titles here. That'll take you back to here, which then gets on your lab guide. Take me to my files, lab reports, personal information. Excuse me. Here's documentation. If you're trying to figure out how to do the practice labs, here's your user guide. Here's some videos to get started with them. But anyway, that's how you work with some of these. So it was requested to cover that, so I went ahead and covered that first. Let's take a look at Chapter 8. Chapter 8 is System Initialization in X Windows. Now, objectives here. We want to summarize the major steps necessary to boot a Linux system. Detail the configuration of common Linux bootloaders. Explain the UNIX System 5 and System D, or SysV and System D system initialization processes. Start, stop, and restart daemons. Configure the system to start and stop daemons upon entering certain run levels and targets. Explain the purpose of the major Linux GUI components, X Windows, Windows Manager, and desktop environment. List common Windows managers and desktop environments using Linux, and configure X window settings. Now, our boot process, we have post, power on, self-test, series of tests run when computer initializes. This ensures functionality of hardware. Not much different than Windows. When you bring up Windows, it checks all the configuration settings. If you say that there's a hard drive out there, it goes through, runs a little program, very low-level program, to make sure that all that hardware's what you say it is. It hadn't changed. Bootloader, program used to load an operating system. And again, there's a loader on Windows. It loads in an operating system. This locates and executes the kernel of the operating system. Kernel is kind of the core piece. Now, the MBR might contain pointer to a partition, contain a bootloader on the first sector. The active partition point to by the MBR, and it's one per hard drive, HDD. We have our /boot. This is a directory containing kernel and boot-related files. I don't know if I can actually go to that in this, but let me try it. Let's see. Change directory root. No, permission denied. We got our VM Linux Z dash kernel version, Linux kernel file. Our daemon system processes that perform useful tasks. Example, printing, scheduling, OS maintenance. We got our initialize daemon, first process started by Linux kernel, and this loads all the other ones and brings system to a usable state. This is not much different than how Windows works. They have different terminology and their infrastructure is different, but same idea. You'd be surprised if you actually looked and saw how many processes are running on Windows. You'd wonder how it has time to even do anything for you. Here's our boot process. We got our BIOS of the machine, then goes to the post, and then our MBR, and then goes through all the bootloader and bootloader and so forth. Primary function of bootloaders: load the Linux kernel into memory. Other functions: passing information to the kernel during startup, booting another operating system known as dual booting. I never have done this, but some people will set up different operating systems on one machine. Maybe they have Linux and Windows. I'm assuming that's what it's referring to. Like I said, I never have done that. Two most common bootloaders: Linux loader, LILO. We got our Lilo. Grand Unified Bootloader, GRUB, Grub, and Grub2. The Linux loader, traditional Linux bootloader, no longer used by most modern Linux distributions, often found on other distributions that require a smaller bootloader than Grub. Typically located on the MBR GPT, the Lilo boot. Prompt appears following BIOS post, allows choice of operating system load to startup. And to configure, you edit etc Lilo conf file. Probably won't be able to see that. No, I didn't figure I would, because this is a instance of Fedora. I thought even from a security standpoint, I probably wouldn't even view it, but I thought maybe I could see it. Configure, edit that file. May be hidden. So let's try to edit the etc and then that file. Okay. And assuming I got the name right, that didn't bring anything up. Here's the different keywords that you'll find inside. So these are all the different items you can configure. See, for example, prompt displays a Lilo boot prompt provided there's no message keyword specified. And with these go other options, which aren't listed here. These are just talking about the keywords. Like append equals keyword. Useful for manually passing information on Linux kernel. Can pass almost any hardware information. Must reinstall Lilo if etc lilo.conf file altered. Lilo command reinstalls Lilo-u uninstalls it. Error messages L, the first part of the bootloader failed to load, probably because of hard disk parameters. And you can read all those other ones. Okay, originally created to replace the Lilo. Stage 1, first major part of Grub, typically resides on the MBR/GPT. Remaining parts of the bootloader, stage 1.5 and stage 2, reside in the boot grub directory. Just trying to see what I can get to here. I do got a loader. entries. Permission denied. Okay, and see what stage 1 does there. Stage 2 performs actual bootloader functions, displays the graphical bootloader screen. And here's what you see. Press any key to enter the menu, and it tells you booting Fedora in 1 second. To configure, edit the /boot/grub grub.conf file. Read directly by stage 2 bootloader. HDDs and partitions are identified by numbers. I can't really show you an example because I can't get the file, or there isn't one on that virtual machine. I'm not that familiar with that one I downloaded. Grub boot partition. Partition contains stage 2 bootloader and the grub.conf file. And grub normally allows manipulation of bootloader during system startup. To prevent this, password protect the grub modifications during boot time. And if you press any key during the first 5 seconds after the BIOS post, you'll get a graphical grub boot menu screen. This allows you to manipulate the boot process, get a grub prompt to enter commands. And it says help screen provides a list of all available commands. Google probably even does a better job of that. Grub install installs grub bootloader, typically for reinstallation when grub becomes damaged. Here's a boot menu. You've probably seen items like this if you've gone into Linux. Now, it's Grub 2. Now, this is the most common bootloader used on modern Linux systems. So it's similar to Grub, but Stage 2 loads a terminal-friendly bootloader screen. Main configuration for Grub 2 is boot/grub/grub.cfg. When a new device driver needs to be loaded by the bootloader, the package often adds a file to /etc/default grub.d. I don't think I can see that, but maybe I can. Not a directory. What is it? Okay, guess it is a file. It's not an executable. I was checking to see if it was an executable. Nano grub. Actually, cat. It's our timeout 5. So if I was able to access this, which I'm not, because this is owned by root, I just got read access. But if I was able to access it, here's where you can change that timeout that they talked about. And other options you set. Excuse me. Here's Grub 2. See, we've got 2 options on here. Configure, edit, add or modify existing file lines within the etc default grub file. That's where I'm at. After modifying the file or adding scripts to the etc grub.d directory, then run the make configuration command to rebuild that grub CFG file. Use grub 2 install command if the grub 2 bootloader becomes damaged. Again, this is controlling how your system's going to come up. Your Linux initialization, a kernel resumes control after Linux is loaded. executes first daemon process, init daemon, which then performs a system initialization process and brings the daemon or system into a usable state. Recent Linux distributions have adopted the system system initialization process. Older Linux systems used a UNIX standard called SysV, the 5. System D is completely compatible with SysV, implements new features for management. And two SysV system initialization processes are the traditional SysV and Upstart. In both systems, a init daemon runs a series of scripts to start other daemons to provide system services. The init daemon is responsible for starting and stopping daemons after system initialization. We got run levels. Run level defines the number and type of daemons loaded into memory and executed by the kernel. The init daemon responsible for changing run levels, often called init states. There are 7 standard run levels, and we'll see a table here. Run level command displays current most recent run level. I don't know if I can actually do that. Yes, again. Okay, init command changes the run level on the system. Tail init command aliases to init command. Here's our different run levels. Graphical mode. System that has the same abilities as extended multi-user mode with the graphical login program. Systems that use the GNOME desktop. The program is called GNOME Display Manager, GDM. And it started on TTY1 or TTY7 to allow for graphical logins. I'm assuming even though I'm in the terminal window here, the fact that it says 5 is because I have the GUI over here. We got our Etsy init tab, so initial table. That's otherwise specified. The init daemon enters a default run level indicated in that file. Etsy init tab. What I'm talking about here is these are just files. For this particular operating system, you see that this init tab is no longer used. System D uses target instead of run levels. Multi-user target, graphical target. Again, that graphical, I guess, is a 5 we looked at. To view current default target, run this. So system ctl get default. Graphical target. Okay. Contains a single comment line that configures the default run level. Not on Linux system we're looking at, but there's different versions, different configurations. Okay, runtime configurations, RC scripts that prepare the system, start daemons, and bring the system to usable state. The init daemon executes scripts for default run level 5. Etc rc.d. rc.d. And rc5.d. That says script, even though it's a folder. I wonder if it's also, let's see, ls-al. No, they're actually directories. Looks like these are all linking to other locations. And rewrite execute, full permissions on everything. I don't see the file they're referring to, though, or the script. Execute all files that start with S or K in this directory. I suppose just because we don't have any. It's the reason why I don't see any. When the user specifies run level 1, the init runs the default script but executes files in the rc1.d directory. Probably if I went there, there might not be any. Let's see. Change directory rc1.d. I don't see any in there either. Now, I don't know what these are. They might be scripts. Might be executables. Binaries. Cat K90 network. Oh, those are scripts. So it is running all of these when it goes into one of those modes. Says enter stop, depending on whether the symbolic link file name started with an S or K. S to start, K to kill. Okay, these are all start with K. Here's a flowchart of a traditional Unix SysV system initialization process. We got our init daemon. And it goes out. It's got that etc init tab. Sets the default run level to 5. Goes out to /etc/rc5.d. And as we saw, there's links to other locations on there. And handles it appropriately, depending upon whatever the system needs are. And then your daemons for run level 5 are executed. On Linux systems that use the upstart init system, the /etc rc.d directories are not used. The init daemon identifies the default run level in that init tab file. Directly executes the RC scripts with the /etc/init.d directory. Each daemon has a separate configuration file within the etc init directory. Uses standard wildcard notation to identify run levels. It should be started, or stopped in. And it shows you the sequence. So you got your init daemon, and it's going out to that init tab, and also the /etc/init, looking for files. Let's start that list that daemon configuration files that list, start, and stop run levels. And then we've got our /etc/init.d, RC scripts executed for daemons that should be started and run level 5. And then the run level 5 is executed. Most of your daemons accept arguments start, stop, restart. Can be used to manipulate daemons after system startup. For example, to restart the cron daemon, type this, etc initd. Restart. Probably be denied if I had to guess. No such file or directory. Of course, this may not match our system. What if I can just do a cron restart? Not even finding the file. Cron tab, I think it is. Let's see. Control C. Dash E, edited, dash L list users cron tab. Cron table. Let's try that again. No cron tab for OS boxes. I haven't set up any process to run. This the idea behind this is you can with the cron tab you can schedule something to run in the middle of the night. Well, in order for it to run in the middle of the night, it has to have a little process running, a daemon process. So that's what we're talking about if you need to restart it for some reason. You need to stop it. Why would you want to stop it? Well, let's say you don't want it to run tonight, but you don't want to bring your system down. Yet you don't want to change your schedule that's set up in your cron. To configure a daemon to start or stop in a particular run level, create or modify symbolic links within that /etc/rc whatever number .d directory. Do our check config command, view and modify daemons that are started in each run level. Check config. Shows you 4 or 5, which ones are on, which ones are off. So you can look at those. Use the update -rc.d command to configure files within that etc/rc like 5.d directory. Let's try to think if it'd let me do that. Probably would. I don't know. That might be at the user level if I looked at 5. Now, working with the systemd command systemization process, systemd is similar to SysV, can be used to start, stop, and configure many other OS components. Each OS component is called a unit, and daemons are often called system service units, and run levels are called target units or targets. Now, we're probably going to find that more of the commands will work on this. This tells us our targets again, and the graphical target is run level 5. Default target on a system with a GUI installed is a graphical.target. We saw that with that command we did earlier. To configure a different target, update the etc systemd system. I doubt if I can see that, but etc systemd. I can. System, then default.target. Oh, I hate how there's some mock links. Excuse me. Okay, I'll just scroll. Might be easier to see. Here's default.target. Looks like it's /lib/systemd/system graphical.target. Okay, so that's our default target set for our current setup. I do like the color scheme when it does that. That's why I hate when you pipe it into something else, it loses the color scheme. Or I haven't figured out how to write it anyway. To configure a different target, update that link. Here's your systemd system initialization process. We got our init daemon again. It goes out to the /etc/systemd/system default target, which is a symbolic link to somewhere else. Let's see here. Your default target is pointing to a different location. Lib systemd system. So see, we've got our graphical target, sysinit target. What other targets are there? A init target, kexecute target. So, by the way, you can point it to a different target. And this talks about how the multi-user.target wants /* symbolic links to the RC scripts in the user lib systemd system directory, and then your daemons for multi-user multi-user dot target is executed. Systemtl command uses start and stop daemons, as well as configure them to automatically start during system initialization. So systemctl restart cron_d.service. Let's try that. Okay. System control. Restart cron_d.service. And coming up, asking us to do authentication on this. I'm guessing it won't work, but let's see. osboxes.org. Not sure enough to work. The reason why is this cron that we're looking at here is just unique to our own user. Remember how we looked at that cron tab earlier and we didn't have any items out there? So that's why it allows me to restart it just for myself. Probably wouldn't let you do much manipulation on systems or binaries, shell scripts that are being run via the root sign-on. Status sees detailed information. Arguments. Let's see, it's loaded. It's currently running. Use the full name there. It's been running since March 19th. Today. So I guess when I signed on, did I sign on? 59 seconds ago. Then our process ID, number of tasks, memory being used, then all these different information. So do a Q to quit that. There's a way to view all of your processes. I don't know if I remember the exact command. PS? No. PS -- help. PS - all. More. So you have things controlling your mouse. As I'm moving my mouse around, I can see it. Lots of other items that are being run. That's still not what I'm looking for because I don't think I saw a cron in it. Excuse me. Didn't sleep very good last night. Enable, configure a daemon to start in the default target, isolate, change between targets. Here's your X Windows system. You got Linux GUI components, graphical program, your X clients, desktop environment, window manager, X Windows, and video hardware. X Windows, core component of Linux GUI. It provides ability to draw graphical images and windows that are displayed on a terminal screen. Sometimes referred to as X Server. X Client, programs that tell X Windows how to draw the graphics displays results. Need not run on the same computer as X Windows. I have to think about that one. Wonder why it doesn't need to run on the same computer. X386 OSS version of X Windows, originally intended for the Intel x86 platform. Now, Windows Manager, desktop environments, modifies look and feel of X Windows. Seems like everyone has a different look of what they're trying to achieve. Fedora seems to be very minimalistic view. Desktop environment, standard set of GUI tools, works with Windows Manager, provides standard GUI environment, provides toolkits to speed up process to create new software, and KDE and GNOME are the most common. Here's common Windows managers. I can go over all those. K Windows Manager. Window Manager works under KDE. Qt Toolkit, software toolkit included in KDE. GNOME desktop environment, default desktop environment in most Linux distributions. Uses Mutter Window Manager and GTK Plus Toolkit, and can configure KDE or GNOME to use different Windows managers. I haven't done much customization there, to be honest. Whatever comes up with the operating system is what I work with. So if I download Fedora this version, then I go with the defaults. Starting and stopping X Windows. When the init daemon boots to run level 5 or graphical.target, the GNOME Display Manager starts. Displays graphical login screen, allows users to choose a desktop environment. If you choose 1 or 2 through 4, the GDM is not started by default. 5 is our graphical. Type StartX at a character terminal to start X Windows and use the default Windows Manager. Assuming it's installed on whatever version you're looking at. Configuring X Windows. X Windows interfaces with video hardware, requires information regarding keyboard, mouse, monitor, and video adapter card. Again, there's a lot more things that has to take into effect when you start looking at the GUI side. Attempts to automatically detect required information. If automatic detection fails, user needs to specify correct hardware information manually. User configured settings are stored in files under the etc x11 xorg.conf.d directory. Common settings such as the display resolution can be modified using the displays utility within the GNOME desktop environment. You can manually run the system.-config-keyboard command to configure the keyboard. And use xvid tune utility to fine-tune the vertical refresh rate, vsync, and horizontal refresh rate, hsync. Here's how to select a keyboard. Here's xvid xvid tune utility. And then our summary. And that's the end of that chapter. So we'll go ahead and stop there. And I'll put the assignment out for that. Yeah.